Annyeonghaseyo, ni hao, sawadee ka, bonjour, hello. This is my friend Cielo.
Oh yes, just say, this is my friend Isabel. What time is it?
It's calculus time, and we will solve about optimization equations. In this video, we are given a task to optimize the box volume. And we are given this figure in which each corner of this sheet is cut by smaller squares with a side of x.
The task is to find its maximum volume if the sheet is also a square with sides equal to 30 and is folded into a box.
When you fold edges, it will become a box like this, and the height is equal to x, which is the length of the square, and the length and the width of the box is equal to y, and y is the left portion, which is not cut. Optimization problems involves two equations. The first is the constraints, and the second is the optimization equation. And there are 8 simple steps to solve optimization problem.
So the first step is to set up the constraints. 2x plus y is equal to 30. Constraint is the quantity that is true regardless of the solution.
In step 2, we set up the optimization equation, and A is the maximum volume. Volume is equal to length times width times height. However, in this equation, height is already x, and then length times width becomes y times y, or is equal to y squared.
Step 3 is using the constraints to solve for one variable in terms of another. From step 1, 2x plus y equals to 30, became y is equal to 30 minus 2x. Step 4 is to substitute step 3 to the optimization equation and simplify. From step 3, y is equal to 30 minus 2x. A is equal to x times the quantity of 30 minus 2x squared. Following the format of squaring binomials, a squared plus 2ab plus b squared. X times the quantity of 900 minus 120x plus 4x squared. Equals to 900x minus 120x squared plus 4x cubed. Step 5, find the derivative of step 4, in which a is equals to this. A prime is equals to 900 minus 240x plus 12x squared.
In step 6, set the derivative to 0, or simply copy the derivative and equate it to 0. And the numbers look a bit large, so we will divide it, or by 4 rather, in both sides, and then we obtained 225 minus 60x plus 3x squared equal to 0. And we can factor it out into quantity 3x minus 15 times the quantity of x minus 15 equals to 0. And then, in step 7, simply solve for the unknown. Set the quantity of 3x minus 15 equals 0 and x minus 15 equals 0. And simply isolate x on one side and the numbers on the other side. So, in 3x minus 15, we obtain the value of x, which is equal to 5, or using the unit, can say that the side is equal to 5 inches. Meanwhile, in x minus 15, we obtained that x is equal to 15. So we have two values for x, which is 5 and 15. In step 8, find the other unknown using the constraints. We'll solve for y. Y of 5 is equal to 30 minus 2 times 5, and then we obtained y is equal to 20, or 20 inches. On the other hand, if we use 15 for x, we obtained a number of 0 for y. It would be invalid to say that the length of y is 0. So we would rather choose 5 as the height and then 20 for the length and width of the box. A is equal to the maximum volume of the box, in which A is equal to xy squared, where x is equal to the height, which is 5 inches, y is equal to length and width, which is 20 inches. We will now substitute them to x and y, and 5 times 20 squared is equal to 2,000 inches cubed. So before this video ends, Cielo already passed out, so we have a proxy or active subscriber, Rhoda. So did you learn something while watching everything?
Yeah, I learned a lot.
Wow! So Rhoda, can you give me the two equations involved in optimization problems?
Constraints and optimization. Proxy to Edith.